Good day, I'm Peter Foy, Technical Marketing Manager with GD32VW553. Today I'm going to review the VW553. I'm going to show you how to get started using Wi-Fi 6 and BLE. So first I'm going to introduce you to the GD32VW553. I'm going to introduce you to the different modes that it supports, and then we'll go through an access point Wi-Fi demo. The GD32VW553 supports both Wi-Fi 6 and BLE 5.2 under Wi-Fi 6, 802.11 BGNAX, and then we also support WPA3 in enterprise mode. Under BLE 5.2, we have a high-speed 2 meg and a 1 meg PHY. Long-range coded PHY includes both 125 and 250 kilobits per second support, and then we also support BLE mesh. Both the SoC version of the chip, and we also have modules available that support up to 105 degrees C. Memory consists of 256K of ROM, 320K of SRAM, and either 2 or 4 megabyte of flash. We also support coexistence, of course. You can have both stacks running, Wi-Fi 6 and BLE 5.2. We also support Matter over via Wi-Fi. So there's example designs of that in the SDK as well. So digging a little bit deeper, the GD32VW553, it is a 160 megahertz RISC-V machine with a double precision floating point unit. It supports both SoC standalone and NCP mode via UART. There are multiple power modes to reduce system power. You can individually power down either or the Wi-Fi or the BLE, or both at the same time. We also support target wake time under Wi-Fi 6. That increases efficiency as well and lowers power. And then under Wi-Fi 6, we support the OFDMA, the MIMO to increase network capacity and lower latency. We support Wi-Fi and station access point mode. Concurrently, we can support Wi-Fi and station with BLE instantiated, and then Wi-Fi and soft access mode with station support as well. Under security, we support secure boot and over-the-air updates. We have a secure key storage that is actually housed in the eFuse area of memory. And then we also have true random number generator. We have cryptographic acceleration units, hash acceleration units to support security as well. Peripherals include one USART, two UARTs, two I2C, one SPI, and one QSPI, along with an infrared ray port. And then one 12-bit ADC that supports 9 channels at 3 megasamples per second. All the SDK examples use FreeRTOS, and then we also have support for Azure Cloud connectivity in the SDK. IDEs that are supported in the SDK include GD32's GD32 Embedded Builder, as well as Sager's Embedded Studio. You can also use IAR or Kyle to support your designs as well. So the 553 can be supports 2 different modes. SoC mode. SoC mode is standalone. The application will run on the RISC-V machine as well as both stacks. In NCP mode, or network coprocessor mode, you have an external host that houses the application, and then you interface to the 553 via UART and send it function calls. So to get started with the developing with the VW553, I would suggest that you get the eval kit, download Embedded Builder. We also have, of course, a datasheet and user manual. There's also developer documentation that you can download. The Wi-Fi BLE software development kit's available, firmware library, and then demo suites are available as well. So we're going to go ahead and get started with Embedded Builder. And the demo we're going to do today is a standalone mode. And then we're going to interface to and download the code via GD link The GD link is actually embedded or included on the eval board, so you don't have to have a separate piece of hardware for that, just a USB cable. And then we also are going to print some information back to the tiered term window via the UART port as well. Okay, to begin with the demo, what I'm going to do is I'm going to show you where to download the tools, the SDK, etc. So you're not going to go to our main website, which is gigadevice.com. You're going to go to GD32MCU.com. You can go to the download section here. We're going to go over here and select the VW5 MCU, and then you can see where we have all the data here. You can have a data sheet, user manual. I'd suggest you download those. Most importantly here, we're going to download Embedded Builder today, and then also the SDK. So download those two files, and then you can join me in just a minute. After you download and unzip Embedded Builder, you can put it under program files. That's what I've done here. There's an addition that you need to make to the toolchain. So to compile for the BLE Wi-Fi SDK, you're going to need this Nuclei Toolchain. So we need to go get that next. So the URL for that Nuclei Toolchain is nucleisys.com, download.php. We need the RISC-V toolchain here, and under Windows, we don't need the latest one. We need version 2022.04. So we're going to download that. Okay, after you download that, like I said, unzip it, and then you're going to put it in that tools directory under Embedded Builder. I have downloaded the SDK and I'm unzipped it here in this directory. So I would suggest that you do that next. The next thing we're going to do after you have all the tools and the tool chain installed, we're going to actually open Embedded Builder. I've created a shortcut here on my desktop. We're going to go back out of here. We're going to go into that new directory I just created, and we're going to go into not the mutable bootloader. We're going to go into the SDK here. There is a project here that's all-encompassing for the Eclipse, but we're not going to do that for this example. We're going to go under Examples. We're going to select Wi-Fi, and this is going to be the directory that we select. So that's the directory for our workspace. Examples Wi-Fi. We're going to launch the tool. We're going to accept the license agreement. So next one we're going to do is open or import that source file from this TCP server. So under that TCP server, there's an Eclipse project directory. We're going to select that folder. So that'll automatically come up with the Eclipse project here. We're going to select Finish. We're going to close this Embedded Builder splash screen. And here we go. So under main, there is a TCP server.main file. And we're going to go and let's just go change the password here. So that's the first thing we have to do. Next thing we need to do, we need to make sure that we can print using printf. And yes, we do. We have config debug print enabled. The next thing that's not very obvious, we need to make sure instead of, or that we have the eval kit selected as our platform. So we're going to go under File, Open File. We're going to go to that directory, and there should be a config directory and then a platform header file. So we're going to open that platform header file. And under the platform header file, we need to change that from the starter kit. We have the board selected as a start kit, but we're using the eval kit. So we got the correct board or platform defined now. Make sure we can print to the debug port. So that should get us where we need to be. Next thing we can do is we can build the project. Oops, I forgot to make sure that we have the correct tool instantiated. Let's see what happens first, and then I'll go back and make sure that you are aware you need to select where you need to select that tool chain. So this is going to take a bit. Okay, just by coincidence, my tool chain was set correctly, but we need to make sure that yours is. So we're going to right mouse click on project, and we're going to hit properties, and then we need to make sure we go into under C++ build, and then under settings, and then toolchain settings. So we're going to set it to the toolchain name, we're going to set it to the Nuclei Toolchain, and then we're going to browse to this GCC bin directory underneath that toolchain that you just unzipped, installed in that tools directory. So then the build path would be under build tools, that version, and then the bin directory as well. So make sure you have that set before you do the compile, or otherwise you're going to get errors. So you can go back in here and clean the project. I would suggest you clean the project, and then you build the project again. Okay, the project has finished building. So there is an L file here that we need to program. So to do that, you go here, and then you can select run as, but it's going to give you a message saying they can't use that. Instead, use a download tool, and we're going to be at hex 800,000. Select OK. Looks like we do need to go configure run as. Then it's going to give us, doesn't know what the download address is. Let's go back in here and use a download again. And now, so you actually do have to go configure it under run as. Then after you configure it under run as, then you have to go to flash download. Now that the flash download's complete to our development kit, let's do something else here. So we're going to print out some messages back to the UART, to a terminal. So we could open up TerraTerm, but there is a terminal window we can open up down here. We can select that little icon there. It is COM5, baud rate's 115.2, all that looks good. Next thing we can do is go over to the development kit and push the reset button. So let's go ahead and push the reset button here. Okay, looks like we have the test access point successfully started. So let's try to go hook up to it with my smartphone. Let's do that next. Okay, so I've gone to settings in my Apple iPhone, and we're going to go to Wi-Fi, and we see that test_AP is there as a network. We've already got the password in there, and we're going to go ahead and join the network. So you can see we joined the network, and that's the end of this demo. So again, this is Peter Foy. Thanks so much for joining me today for this session. Please join me for a BLE demo on the 5553. That'll be my next video. Thank you.